Hello guys, in this video we'll build our own time tracker, a desktop application with Tauri 2.0 using Rust. A time tracker application helps us track since how long the application is up and running on our machine. Now there are tons of time tracker application with very rich features. So in our time track application, we'll track how long an application is up and running on our machine, how much resource it's consuming in terms of memory. We can also add the CPU consumption as well. So we'll use Tauri for it. We'll build the desktop application and use React for our UI. We'll add the React components, and for our business logic of detecting the applications that are running on our machine and how long and the max, we'll do it in Rust. So without further ado, let's get into it and let's start coding. As we start, there is a link to my Discord in description. Make sure you join it. We are building a community of like-minded people where we share our thoughts on different topics. We do lots of discussions, not just Rust, but a lot of different topics and off topics as well. And I share a lot of tips and tricks related to Rust programming language, so make sure you join it. First of all, move to the Project Explorer. Make sure you are in a clean directory. Open the terminal. Now, as always in my videos, I'll be using yarn as the package manager. So we'll just do yarn create Tauri app. Now here we have to quickly fill up some details related to our project. So let's say the project name will name as time tracker, and let's say com.timetracker.app as the identifier, and we choose our language for the front end as TypeScript and JavaScript, and yarn as the package manager, and UI template as React, UI flavor as TypeScript. That's all that we need to provide, and we can close our terminal. And as you can see, a new directory is added in our time tracker directory. So this is all the skeleton of our project. We have src Tauri where we can add our Rust code, and src where we'll add our React components. First of all, let's move to the Rust part where we'll add our business logic to detect the applications which are up and running and how long are they running, the application which is max running, and all our features, the logic of the features. And then we'll move to the React part where we'll add our components. So let's get started. First of all, move to the terminal and move to time tracker and move to src Tauri. Now here we'll just do a cargo add sysinfo as the crate that we need. So once we have our crate, we'll just go ahead to our librs, and here we can just remove the default structure Tauri command, and we'll start adding our own Tauri commands. Now let's add our struct to understand what features we'll be providing. So struct app info, and this is the app ID or process ID, name, and running time formatted. So a formatted string showing the running time in terms of days, hours, minutes, and seconds, and then memory in byte as U64. So we'll be providing two features for all the apps that are up and running on our machine. We'll show since how long are they up and running and how much memory is consumed. So you can also add additionally the CPU consumption as well, but I'll just stick to the two features that we need. Derive, and okay, and now let's add our first Tauri command, which is to list our up and running apps. So fn list process, and we'll just return a vector of app info, let mutable sys system new all refresh, and let mutable processes or apps, whatever you want to call it. Sys.processes .iter .filter, and we just want to access the process here, and then let's call maybe is valid and pass the process. Now let's first of all implement is valid. So is valid helps us to filter the process, and why do we need it, we'll just discuss in a minute. So because there could be thousands of processes running on our machine, and there's no way to detect using sysinfo that which one are user application, which one are helpers or required for just executing. So for that reason, we'll just use a custom function to detect if it's a user process or it's an application. And how do we do this is using a fuzzy match logic, but yeah, that's what we are doing here. So let's say a vector of helper, so service, so any process has any of these keywords, then we don't want to show these. And when you do filter out these, you will see a lots of service or user non-user application processes will be filtered out. And then we'll just do if let sum exe path process dot exe unwrap dot to str let is in app directory. Now we'll just also check if it's running in an application directory, and for that we'll just add constant application directory for our different OS that we have. So let's say application directories, and for example, for our case of Mac OS, we have applications that are running in mostly slash applications or slash users slash star applications. So this is mostly where our apps are running in Mac OS. So we'll just add cfg, give me this, when target OS is Mac OS. Similarly, we'll just copy this and we'll say in terms of Windows, give me C program files. So this is where the executable directories are for our applications and that are on Windows. So program files x86, and similarly we just add another one which is for Linux. So here we'll just say give me whatever is in slash user bin up and running on these, or user local bin or slash opt. So this is for Linux, this is for Windows and for Mac. Now we'll use this to filter out. So for that we'll just do is our exe path dot contents, or actually we can just do is our application directories dot iter dot any directory exe path dot starts with directory. If that's the case, then we have our app, and another way to identify our app is helper. So if it's helper, it's not our app actually. Iter dot any and keywords. So we'll just do is process dot name dot to string Lucy to ASCII lowercase contains keyword. And finally, so process dot status is equal to process status dot run. So if it's in running and is in app directory and not is helper. So that's how we identify that it's an application, a user application that's up and running. Otherwise we just send out false. So that's how we detect is valid, and if it's a valid, then we just map. And right here we need both, so we need ID and process, and we'll just do is collect, and here we'll just do app info, so name as process dot name dot to string Lucy into ont, and running time formatted we'll add in a minute. Memory in bytes, we'll just do is process dot memory, and for this we'll just add formatted running time or format running time and process dot runtime. Now this is in seconds, so we have to add a format to this, so let's quickly give it a format running time. We get seconds and U64, and we return a string. So we extract the days from seconds, divide by 86400, and we extract the hours, which is seconds mod 86400 divide by 3600. And similarly we extract minutes, which is again seconds mod 3600 and divide by 60. Similarly we extract seconds, which is seconds mod 60, so the leftover seconds, and then we format. And how do we do this is 02 days, and similarly hours, similarly minutes, seconds, and then we just do is days, hours, minutes, seconds. So that's for the formatting. Now let's use this here and we collect it. So the final thing that we do is process, which is our processes dot sort by and a comma b, a dot name dot to ASCII lowercase or to lowercase, and we'll compare b dot name dot to lowercase. So this is for the sorting, and then we just return the processes. So this is how we list our process. Tauri command. Now this is a Tauri command to list the process. Now let's quickly add to compute max memory and max time. Now let's add max memory. So we'll just add a max memory command that returns optional of app info. Why optional? Because if there are no process up and running, we have to handle for that as well. Now here we'll just copy this much, paste it here, and we'll just return directly. So remove this, remove collect, and here after filter we'll just do max by key, and then we'll just do is process and process.memory. So it will max by process memory, and at the end we just return. Let's add id. Did we add? Okay, let's add id here as well. So we'll just do is id dot to string, and same we'll just do here is id dot to string. Now let's add Tauri command on top of this. So once we have our max memory, we'll just copy this and add max running time as well. So for this, we'll just do is process dot run time, and everything else remains as it is. Yes, so let's now add the invoke handler for these. So list max, and the final one, which is format running time. Sorry, the max memory. Actually, we have to rename this to max time or max running process, a better name. So we have our all the commands in the handler, and now we'll move to the React part. If you have any questions, queries related to this, feel free to leave in the comments. So let's move to the React part. Now let's move to the React part to add our UI. So move to the terminal, and here first of all we'll move to our project and add dev dependency to add the Tauri app CLI. Now there we have our dependency added. So let's go ahead and add our component. So we have our app tsx where we'll add all of our main UI, and make a process card tsx where we'll add our cards UI for showing the max running time, the max memory. So let's first of all add the card component. So let's add our props interface and process card props, title as string, and then we have process which has an id as string, and name as string, and running time as string which will be formatted, and memory as number. Now let's add the process card react fc process card props, and here we'll just pass our title, process, and return div with class name as process card, and an h3 to show the title, and then a p tag to add process name, and id as process id. And similarly we have another p tag which is running time, runtime, and lastly we have one more which is memory so all of this, and finally we just export default process card. So this is kind of a reusable card where you can pass any of the details of the process and it will show up as a card. Now in the app tsx we'll add rest of stuff. So let's add our interface, process info, id as string, name as string, running time as string, and memory as number, and then const app react fc, and we don't expect anything here, so const some states that we have to add, processes, set processes, and use state. So process info as an array and initially an empty array. So that's our first state that we need. Similarly, we need is const max memory process, set max memory process, and use state. That would be just process info or null, and initially we'll set it to null. Similarly, we'll just copy this and max process, max memory, max running, and we'll name it to max running. Now once we have this, we'll add a use effect to keep on fetching our data and updating the state. So we'll just invoke a bunch of Tauri commands, const process list, await, invoke process info as an array, and we'll just use is to first make a call to our list process. So now copy this and max memory, and we copy this. Similarly, we copy another one which is max running, and if you add any other then feel free to add here. So max running process. Once we get this, we'll just say set process as process list, set max memory, and set max running as max running. So we have all three in our fetch, and inside here let's wrap it in a function, async function fetch data. So this is a function now, and we call fetch data and const interval and set interval. So call fetch data every 1 second. Now you can change it according to your need, but I'll just keep on calling and updating the time and usage. And clear interval, and then here we just add let's name this as interval. That's all that we need in the use effect. And now let's add a bit of UI that we have. So man, and we add the in the man we add the class name as container, and here we add bit of condition. So if max memory process exists, then we want to add the process card, and here we want to pass title as max memory process, and then processes is equals to max memory process. This is if this thing is exist, and just remove one this. Process card. Now similarly we will add another one. Just copy this and we'll name this max running process, and let's rename this to max running process and max running process, and pass the max running process, so that we have for max running cards. Similarly, add a div class name as process list, so all the other apps that we have on our machine will just list them. So map process, and right here we'll add a div and key as process ID and class name as process item, and then span process name and ID as process and similarly we add the running time as well as memory. So just a basic component, we have pretty much everything we need is here. Now let's expose it. So export default app, and now let's add the CSS. So move to app.css, just remove all of this, and I just added this CSS. So either you guys can just pause the screen and add this, or I'll provide the link in the description so you can copy, because no point wasting time on CSS. It's pretty basic. And we have our component ready, we have our card, we have our commands. Now make sure you add all of this so your app could run regardless of which OS you on. Mac, it will automatically pick these directories, for Windows and for Linux. Now let's go ahead and run and test our application for the very first time. So here you go, the first look of our application up and running. As you guys can see, it keeps on updating the seconds because we are continuously checking. So max memory process, and we have the name, it's an ID rest rover, and then time since it's up and running. Memory usage, similarly max running. As you can see, Slack on my machine is up and running for 24 days with the memory and everything, and similarly all other applications. Now as you can see, it's more about application and less about the process, but we had a custom logic to filter the application out from the running process on our machine. So you guys can have a go and let me know how can you improve that logic. So pretty simple, pretty basic, and we can add tons of other features on top of this to make it even more pleasing, and it works like a charm. So that's it for this video, guys. I hope you guys understand and learn something new. If you do like the video, share with your friends. I'll catch you guys in the next video. Thank you.